Hello everyone, welcome back to the computer network series. Today we are going to dive into how computer networks actually perform. Think about this. Have you ever been right in the middle of a great YouTube video, connected to full Wi-Fi bars, and suddenly it starts buffering? Why does this happen? If you're connected, shouldn't it just work? What actually you think about it? You might think it's just because of slow internet, a weak signal, too many people on the Wi-Fi, or maybe because of server issues. You are absolutely right. But to truly understand why, we need to look under the hood. Today we will learn about four major parameters that determine whether a network is good or bad. The four major parameters are throughput, delay, jitter, and packet loss. Fine. Before we look at the metrics, let's define the core concept. Network performance is simply a measure of how efficiently a network transfers data from the sender to the receiver. Think of it like a highway system. A high performing highway gets cars to their destination quickly and without accidents. In network terms, a perfect network has four characteristics: high throughput, low delay, low jitter, and low packet loss. Fine. Let's look at the metrics one by one. Fine. Moving on, the first metric is throughput. Throughput is defined as the actual rate at which data is successfully delivered from the sender to the receiver. This is measured in bits per second, kilobits per second, megabits per second, or gigabits per second. Let's clear up a common misconception here. Say for example, if your internet speed that you have subscribed is 100 Mbps, due to congestion, you only received 65 Mbps, then the throughput is 65 Mbps. To picture this, think of a water pipe. Fine. The pipe's maximum capacity might be 100 liters per minute, but because of dirt or built up inside, only 60 liters per minute actually comes out of the other end. So the actual water reaching at the other end is your throughput. Fine. So now how throughput is calculated? Throughput is calculated by the formula actual amount of data received divided by time. Let us look at an example. A file of size 500 MB is there and it is downloaded in 100 seconds. Convert into bits, throughput will be 4000 divided by 100, which is 40 Mbps. Fine. Moving on, let's discuss the factors affecting throughput. There could be a lot of factors that affect throughput. It's affected by network congestion, your overall bandwidth, the speed of your routers, transmission errors, and even the physical distance. Let's do a quick check to see if you have got this. Look at the activity below, which has higher throughput. Number 1, student A downloads 100 MB in 10 seconds and student B downloads 100 MB in 20 seconds. Obviously, the answer is student A. Fine. Moving on, the next metric is called the delay or the latency. Delay is defined as the time taken for a packet to travel from the sender to the receiver, and this delay is measured in milliseconds. For example, assume that you send a WhatsApp message to your friend. The message reaches your friend after 40 milliseconds. So now here delay is 40 milliseconds. There are four important types of delay. Number 1 is the processing delay. This delay occurs usually inside the router. The time required for checking the errors, reading the destination address, deciding which hop to take, all contributes to processing delay. Fine. Number 2 is queuing delay. Packets wait in a queue because many packets arrive together and the device needs some time for processing the packet. Imagine people waiting in a bank queue. If there is a queue which is very long, the waiting time is going to be again long. Fine. Number 3 is transmission delay. This transmission delay is the time required to place all the packet bits onto the transmission medium. How do you calculate transmission delay? It is the packet size divided by the transmission rate. For example, a packet which is 1000 bits is transmitted along a communication channel whose link speed is 100 Mbps. The delay is going to be 10 microseconds. Fine. Moving on, the last delay is called as the propagation delay. Propagation delay is the time taken for the signal to travel through the communication medium. It is the distance divided by the propagation speed. For example, if the distance is 300 km and the propagation speed is 3 into 10 to the power 8 meter per second, your propagation delay is going to be 1 milliseconds. Fine. So how to calculate the total delay? Total delay will be the sum of the processing delay, queuing delay, transmission delay, and the propagation delay. The second important metric is called the jitter. Jitter is a variation in packet delay. Not every packet reaches at the destination exactly at the same time, is it not? For example, packet 1 20 milliseconds is being taken. Packet 2 24 milliseconds. Packet 3 18 milliseconds is taken. For packet 4 40 milliseconds is being taken. The delay is changing. It's not the same between each and every packet. This variation is called as jitter. Say for example you do a voice call. The voice packets arrive at different times. So how do you get the voice connection? Your voice call could be broken, there could be echo, or there could be some sort of distortion. So all these are mainly due to jitter. Fine. So what could be causes for jitter? Congestion in the network, packets taking different routing paths, queuing delay could be one possible reason, and the network instability could be another reason. So which applications are sensitive to jitter? Online gaming, Zoom, Google Meet, voice over IPs, and live streaming are examples, applications which could be prone to jitter. A very classical analogy to jitter is this. Imagine buses are expected every 10 minutes. Instead, the buses arrive in this order. In 8 minutes, 12 minutes, 6 minutes, 18 minutes, etc. So this intermediate time keeps changing. So that variation is called as jitter. Fine. The last is the packet loss, otherwise called as the drop rate. Packet loss occurs when one or more packets fail to reach the destination. What could be the reason why packets are lost? There could be many reasons. The buffers could be full. Router buffer could be full. Due to congestion, packets might be lost. Packets could be damaged. The communication link would have failed. There could be interference in your wireless spectrum. For example, 100 packets are sent, 95 packets are received, 5 packets are lost. So what is your packet lost? It is 5%. So what is the formula to calculate packet loss percentage? It is lost packets divided by sent packets into 100. For example, you send 500 packets, 480 are being received properly, 20 is lost. Packet lost is going to be 4%. Fine. What could be its effects? Lot of effects like voice call breakage, video freaks, game lags, slow downloads, TCP retransmissions could be possible effects. Let us do a quick comparison of the four metric. Coming to throughput, it is the actual successful data being get transferred between the sender and the receiver. The unit is Mbps. The ideal value should be high. Delay is the time taken for a packet to travel. The unit is milliseconds and it should be low. Jitter is a variation in delay measured in milliseconds and it should be low. Packet loss is the percentage of lost packets. It's measured in percentage and it should be near 0%. Fine. Look at some of the real world applications. Email, important metric to consider is throughput. If it is file downloads, again throughput. Watching a YouTube video, throughput plus delay. WhatsApp, delay. Zoom meeting, delay plus jitter. Online gaming, delay plus jitter plus packet loss. Video streaming, throughput plus low jitter. Fine. So these are three important end of class questions. I appreciate you to work out these end of class questions and post the answers in the comment section. Any doubts? You can post it in the comment section. I'll be happy to explain. Thank you. Happy learning.